This is the first of 3 videos looking at significant figures. So this video is focusing on when you are taking a measurement, writing down the correct number of significant figures. So significant figures come from measured values, whether from some sort of device, whether it's a ruler or a scale or a burette. It's something that's being used to measure some kind of amount. So significant figures are all those digits you are certain of that you can read off the scale of your device, plus one digit that you estimate, called the uncertain digit. So whenever we're using one of these sorts of scales, we have something telling us what our number is in between, and we can estimate exactly where that is. So if we look at this first example right here, we've got a scale that's at this point. We can see that it's between 10 and 20, and in fact we can see it's specifically, right, we can count over and see it's between 14 and 15. So we estimate exactly how far that is between 14 and 15. So the 14 point is certain, but the estimated value, 14 point what, is our uncertain digit. So when we estimate that, we can decide, okay, we think this looks like it's 14.7, but that uncertainty could be a little higher, could be a little lower, could be 14.6, could be 14.8. Sometimes with significant digits, we show that uncertainty, as I've shown right here, where we say plus or minus how much we think it could be off by. Not always, but sometimes. So first one there, we've got 14.7 plus or minus 0.1 grams. Next one we can see is between 100 and 150 easily. Then we can count over, right? 110, 120, 130. So it's between 120 and 130. So we're estimating 120 what? So in this particular example, I estimated 128 milligrams. Again, that last digit is uncertain, so someone might estimate it slightly differently. Next one here, my scale is different again, right? I'm going up by 0.1. So when I count over, I'm saying 8.1, 8.2, and then I'm estimating that second decimal. Whoops. Gotta highlight the right thing though. So 8.35 in this case. Next example here, we're looking at a balance scale in pounds. So when we're estimating this one, looking at where that is, between 144 and 145, and estimating that last part. This one, those gradations are closer together, so that plus or minus is a little more, right? Plus or minus 0.5 pounds. How far off is that exactly? Another balance scale here, this one in grams, and we're going up by even smaller gradations than the earlier one. So when we estimate this, .2440 grams, again, plus or minus that last digit. So plus or minus 0.001 in this case. So all of these ones, we were looking at balance scales. The next ones, which are measuring mass, next ones we're looking at some devices that measure volume. So when we're measuring volume, we have something called the meniscus, and we have to be careful with that. So the meniscus is this curve, right? Whenever we have a liquid in a container, there's some forces of tension between the liquid and the container, which causes this curve to happen. So the surface tension causes a curve. When these devices are made, they're measured so that the markings on them go to the bottom of that curve. So when we're looking at our beaker in milliliters here, we can see it's between 200 and 300 for sure. We're estimating exactly where that curve ends up, approximately at 250 in this one. So plus or minus a whole 10 milliliters when we're looking at something like a beaker. When we look at the graduated cylinder, we have much smaller gradations, so we can estimate much more precisely. So we would estimate that this one is between 25 and 26, and it's at about 25.6 milliliters, again with that uncertainty in the last digit. The pipette and the graduated cylinder, kind of similar here in terms of how we would estimate that one. So we're looking, this one is between 20, be careful with the pipette, it's upside down, right? So it's between 19 and 20, so I would be estimating that somewhere around 19.2. And I might, in this particular case, estimate it to a larger number of uncertainties. So I might say plus or minus 0.5 milliliters, because it's a little harder to be as precise as to the nearest 0.1 milliliter. Same thing with our graduated cylinder. We're looking at 4.3. This one looks like it's pretty much right on the line. So I put that 0 in there, but the 0 is not certain, because is it exactly right on the line? I'm estimating that I think it is. But sometimes we're not so sure about that, right? So we have to put that estimated digit in, and again, we have that level of uncertainty. Thermometer, like the pipette example I had there, I might put a higher level of uncertainty with my plus or minus. So it's definitely above 35 and below 36, so I'd be estimating 35.5 degrees Celsius. But again, I would have that plus or minus a full half a degree. So a little note about burettes in particular, but really anything where you're measuring a liquid, but burettes, because we're trying to be really accurate, it's especially important. And with things like burettes, pipettes, graduated cylinders, you want to make sure that your eye level is level to that meniscus. So looking at 3 examples here, right, if you're looking straight across, where you should, you would estimate this one as 19.5 cubic centimeters, another way of saying milliliters. But if you were looking slightly above, you would be estimating it quite differently than if you looked at slightly below, right? Where your eye is seeing that meniscus depends on your eye being at the meniscus level. Again, with burettes, note that they are upside down in their markings, right? The lower markings are higher up, the higher markings are lower down, because it's looking at how much liquid has been taken out of that particular device. And a second note on digital devices, note that you use all values displayed. So if you have a scale that is showing something to 3 decimal places, you take all 3 decimal places. But that very last digit on the digital device is uncertain, and often it will flicker between one value and another.